Today we're going to take a look at 7.3 absolute value equations. We are going to use the definition of absolute value when solving our absolute value equation algebraically. This gives us two cases to consider. Case 1, where the expression inside the absolute value symbol is positive or 0, and case 2, where the expression inside the absolute value symbol is negative. So let's take a look at our first example, where the absolute value of x minus 4 is equal to 8. So we will start by using our definition of absolute value. Okay, and remember that's where y is equal to the absolute value of x if x is greater than or equal to 0, and negative x if x is less than 0. So let's apply this to the function that we have. Okay, the argument is x minus 4, so we're going to go x minus 4 if, and then to work out its domain, we take our x minus 4 and make that greater than and equal to 0 and solve for x, and we get x is greater than or equal to 4, and then we'll take the negative version of our argument and then take the x minus 4 and make it less than 0 and solve for x, and we get that x is less than 4. Okay, so case 1 is where we want to take the expression inside the absolute value symbol, make it positive, or 0. So we want to take x minus 4, make it greater than and equal to 0, meaning we want the positive. And then case 2, where we want to take the expression inside the absolute value symbol and look at the negative version of that. So we want where x minus 4 is less than 0, in other words, negative. Okay, so let's take our argument. We want it to have the positive version, so we want to go x minus 4, make that equal to 8, solve for x, and we get that x is equal to 12. We want to take our negative version, so we want to go negative x minus 4 equals 8. We can divide both sides by negative 1, and we would get that x minus 4 is equal to negative 8. Okay, so remember, when we divide both sides by negative number, like negative 1, then what was negative becomes positive, and what was positive becomes negative. Okay, we want to solve for x. We bring the negative 4 over, it becomes positive, and we get that negative 8 plus 4 is negative 4. Okay, we're going to verify our answer. And remember, when you verify, it's always in original equation. Okay, no variation of that. It has to be the original one. Okay? So let's take a look at our first solution, which is where x is equal to 12. And so we write the original equation. Remember, we want to show that left side is equal to right side. So plug in 12 for x. And then we want to simplify inside the absolute value symbol. 12 minus 4 is 8. And the absolute value of 8 is equal to 8. And so the left side equals the right side. Okay, we want to use x equals negative 4. So once again, into the original equation, substitute negative 4. We get absolute value of negative 8, and so the absolute value of negative 8 is 8, and so we are right. Left side equals right side. Okay, another way that we can solve for an absolute value function is by graphing. Okay, we're going to use our graphing calculators. And the first thing that you want to do is to enter into your calculator y1. And we're going to enter in the right-hand side of the equation and call that y1. So that means the absolute value of x minus 4. Okay, and remember this is your original, absolute value of x minus 4 equals 8 is the original equation. Okay, and then for y2 you're going to enter in where x is equal to 8. Okay, and to find absolute value on your graphing calculator, you want to go to Math. Okay, and I think you want to go over to hit your right arrow key to where it says number on the top of your screen, and then you want to choose item 1. Okay, and that will give you the absolute value. Alright, when we have y2 equals 8, that means we have a constant function. Okay, that just means that y will always be 8. Okay, it actually makes it easy to graph this. Okay, your window settings, your x, just do x min is -10. X max is 15. Okay, and I picked 15 because one of our answers for x was 12, so we want to make sure that we can see that. Your y min, make that 0, and your y max, make that 10. Okay, so when you graph y1, you're going to find that you will have a point at 0 and 4. You will find that you will have another point at 8 and 4, and of course your vertex is going to be at 4 and 0, and so you can graph that in like this. Okay. And then y2, alright, so that's y1. And then y2 is your constant function. It will go straight through 8. Okay. Alright, and so what we're looking for are our points of intersection. Okay, so we will have one here and one here. And you're going to find that the one on the right intersects at 12 and 8. And the one on the left intersects at -4 and 8. Okay, and you remember how to find intersection points on your graphing calculator. You want to go to second trace, choose item 5, and then find your points of intersection. Okay, alright, so what are we interested in? We are interested in the x values of our points of intersection. Okay, and so then we can tell that x is equal to 12 and x is equal to -4.